Right, so this video looks at the group 1 metals, what we call the alkali metals. We will look at their physical properties, reactions and reactivity, and some of the safety precautions when handling these type of metals. Okay, now what are the alkali metals? Now the alkali metals are the elements in group 1, specifically on the left side of the periodic table, and they are called alkali metals. Okay, so they are the elements in group 1, and specifically on the left side of the periodic table, and they include lithium, sodium, potassium, rubidium, cesium, and francium. Okay, so these are the elements that make up the alkali metals. Now, the alkali metals are very reactive. Now, to the extent that we can not find them in their pure form. Okay, they are very, very reactive. That's one particular feature of the alkali metals. Let's look at some of their physical properties and go on and look at their chemical properties. Now, the first properties of the alkali metals we want to look at is their softness. Now, indeed, the alkali metals are soft. They are soft such that they can be cut by a knife. And the trend is that the softness increases as you go down the group. Okay, they are soft, and to the extent that they can be cut by a knife, and softness increases as you go down the group. Now, what does this mean? Now, it means that if you go back to this slide, you have lithium at the top of the group and francium at the bottom. What this means is that sodium will be softer than lithium, potassium will be softer than sodium, rubidium will be softer than potassium, and the least of them, the one with the highest softness will be what? Francium. Okay, because softness increases as you go down the group. Softness increases as you go down the group. All right, so the group 1 metal consists of sodium, potassium, lithium, rubidium, cesium, and francium. They are soft, and softness increases as you go down the group. Again, they have low density. The group 1 metals have low density. All right, and we'll come back to the trends in density as you go down the group. As density increases or decreases, we come back and look at that. So 1, they are soft, and 2, they have low density. Low density. Indeed, the first three elements, sodium, lithium, and potassium, do float on water because of their low density. They do float on water. Okay, so they are soft, they have low density of lithium, sodium, potassium, even float on water, and additionally, they have low melting and boiling point. They have low melting and boiling point. Now, these three properties set the group 1 metals apart from the other metals, because ordinarily metals will be harder, they will have higher density, higher melting and boiling point, but the group 1 are soft. They have low density, low melting and boiling point. However, they do also have some common metallic properties, such as being good conductors of what? Heat and electricity, and also being shiny. Okay, so let me recap on the properties of the group 1 metals. They are soft, they have low density, low melting and boiling point, they are good conductors of electricity and heat, and they are shiny. So these are some of the properties of it. Remember, we said that they are also very reactive. Okay, we will come back and look at the trends in reactivity as you go down the. Again, they are soft. Now, what you have to know is that the first three elements of the group 1 metals, lithium, sodium, potassium, because of their reactivity, they are kept in oil. Now, you can be asked, why are they kept in oil? Now, it's because we do that to prevent them from reacting with atmospheric oxygen. Okay, and because they are reactive, when you cut them fleshy, they look shiny. Within a few seconds, they react with atmospheric oxygen and form a dull metal oxide. We will look at the reaction of the alkali metals with oxygen, and you see what I'm talking about. So to prevent that, we normally keep them in oil to stop them from reacting with what? Oxygen in the air. Okay. Now the alkali metals also react with water to form alkali compounds, and indeed that's why they are called alkali metals. Now questions are normally asked why they are called alkali metals. You should be able to explain that is because they react with water to form alkali compounds or hydroxide solutions. All right, so these are the properties of the alkali metals. Let's look at their electronic structure, which gives them that unique characteristics. Now, if you look over here, you will see that one unique feature of the electronic structures is that all of them have one electron in their outer shell. Lithium with atomic number of 3 have one electron on the outer shell, sodium with one electron on the outer shell, and potassium with one electron on the outer shell. Now this gives them similar physical and chemical properties. Okay, it gives them similar, and what it also means is that they can easily lose that outer electron and form positive 1 ion. Okay, they all form positive 1 ion. So you can have sodium forming sodium 1 plus. Okay, lithium can form lithium 1 plus, and potassium forming potassium 1 plus. Okay, this is because of the one outer electron they all do possesses, and they can easily lose it, all right, to form 1 plus ion. Now let's look at the trend in their density. What happens as you go down the group? Does density increases or decreases? Now I'm going to show you this table. Now look at the table and tell me the trend in their density. Does it increases going down the group or increases going down the group? Okay, now what happened is that in terms of density, the group 1 metals become more dense as you go down the group. They become more dense as you go down the group, which means that density increases down the group. Now if you come here, you see that lithium is 0.53, sodium is 0.97. Now potassium is the outliner here. Potassium has a density less than that of sodium. Now apart from that, the trend resumes from rubidium to cesium. So as you go down the group, the trend is that density increases down the group. Density increases down the group. Now, I have a question here. It says that water has a density of 1 grams. Which element in group 1 will float on water? Now pause the video and answer. Pause the video and answer. Which element in the group will float on water if water has a density of 1 gram per dm3? Which of them? Now to answer that, if you come here, over here, we have lithium with 0.53, sodium 0.97, and potassium 0.8. They are the only element with density less than that of water, and therefore they are the only element that can float on water. So we have lithium, sodium, potassium being able to float on water. Okay, let's look again at the trend in boiling and melting point. What happened as you go down the group and why? Questions are normally asked around these particular properties of the group 1 metals. Now, the trend is, if you look at this table, you will see that lithium with at the melting point of 181, sodium 98, potassium 64, rubidium 39, and cesium 28. Now, tell me about the trend. What's happening? Is it increasing or decreasing? Obviously, it's decreasing as you go down the group. Okay, it's decreasing as you go down. What about boiling point? Over here we have 1,342, 888, 760, 686. So you see that again boiling point decreases as you go down the group. Boiling. Now, you will always be asked to explain why. Now, you are not going to get a group of elements like this. Probably you may be given lithium and sodium with their own melting point, and you'll be asked to explain why sodium, for example, has a lower melting point than lithium. Now, you have to explain it in terms of their sizes, the trend in atomic radius as you go down the group. Okay, so the explanation is that as the atom get bigger, the attraction between the positive metal ion and the delocalized sea of electrons get weaker, and so the metals become easier to melt and boil. All right, now as you go down the group, if I can go back to the slide, the electronic structure, you realize that as you go down the group, the size of the atom increases. Now what this means is that the distance between the outer electron here to the nuclei increases as you go down the group. All right, the distance between this outer electron in sodium and the positive nucleus is bigger in sodium than in lithium. It's also bigger in potassium than in sodium. So the atomic radar increases as you go down the group. Now, what is the implication of this? Now, it means that as you go down the group, the force of attraction between this outer electron and this one weakens because it's bigger. If it's closer, the love between them is stronger. If the more further they are away, the weaker the force of attraction. Therefore, it becomes easier to remove this than this one here. And it's also easier to remove this one than this one here. And therefore, their melting and boiling point become lower as you go down the group. The bigger the atomic radar, the lower the melting and boiling point. Okay? So make sure you can explain this because questions normally come around this. Now, let's look at the reactions of the alkali metals with oxygen. Now, they react with oxygen to produce metal oxides. The alkali metals react with oxygen to produce metal oxide. Okay, this produces a layer of dull oxide on the surface of the metal. Remember, I said that when the group 1 metals are freshly cut, they look shiny, but within a few seconds they start getting dull because of the metal oxide being formed as they react with atmospheric oxygen. Okay, now the speed with which the alkali metals react with oxygen increases going down the group. Okay, that speed increases going down the group. Now remember, I said at the beginning that they are very reactive and reactivity increases as you go down the group. We will come back and explain it in the next video why reactivity increases as you go down the group. Again, their reaction is oxidation. The reaction between the alkali metal and oxygen is oxidation because there is loss of what? Electron. Remember the acronym oil rig, okay, which we learned in electrolysis. Oil rig, okay. Oxidation is loss of what? Electron. Reduction is gain of what? Electron. Oil rig. So when the alkali metals react with oxygen, oxidation happens because one metal loses electron. All right. So let's look at how they react with oxygen. Let's take the general equation is that alkali metal with oxygen, you get metal oxide. So over here we have lithium reacting with oxygen and we are getting lithium oxide. Now, what are you going to get if sodium and potassium react with oxygen? Write the word equation and the chemical equation down. Pause the video and write the word equation and the chemical equation down. What are you going to get if sodium and potassium react with oxygen? Okay, now you are going to get over here sodium plus oxygen, you are going to get sodium oxide. Okay, lithium plus oxygen, you're going to get lithium oxide. Make sure you can write the full balanced chemical equation. That's important. Now, because the reaction between the group 1 metals and oxygen is oxidation reaction, for the higher tier group, you should be able to write the half equation. Okay, so over here we have sodium losing an electron to form sodium 1 plus ion. Okay, you should be able to write the half equation for all of them, one for lithium and another for potassium. You should be able to write that. Now it's oxidation because there is loss of electron. Okay, sodium loses 1 electron as it oxidizes, and this is how you represent the electronic structure of that. You should be able to write that. Draw the electronic structure and write the ionic equation. All right. Now, how do they react with oxygen? How do the alkali metals react with oxygen? Now, all the alkali metals react vigorously with water. They react vigorously with water, and the reaction becomes even more vigorous as you go down the group, as you descend. Now remember, I said at the beginning that reactivity increases as you go down the group because of the increasing size of the atom as you go down the group. The elements get bigger, the distance between the outer electron and the positive nucleus also increases, weakening the attraction between the outer electron and the positive nucleus, and therefore become easier for it to be lost in reaction. Okay, again, the reaction of the alkali metals with water is exothermic. Now that means that heat is released during the reaction. Okay, now they react vigorously with water. The reaction becomes vigorous as you go down. The reaction is exothermic and releases a lot of heat. In addition to that, their reaction with water also produces a gas, and that gas ignites a lighter spring with a squeaky pop. Now, what is this gas? What gas ignites a lighter spring with a squeaky pop? Pause the video and write it down. Of course, it's a hydrogen. It's hydrogen. Now, another feature of their reaction with water is that when they react with water, if you put a universal indicator in the reaction mixture, the reaction mixture turns purple. What does it tell you about their acidity? Is the reaction mixture a base or acid? Write it down. Okay, so they react vigorously with water. They become more vigorous as you go down the group. The reaction is exothermic and releases a lot of heat. It also produces a gas that ignites a lighter spring with a squeaky pop, and therefore that gas should be hydrogen. Again, the reaction mixture turns universal indicator purple, indicating that is what? Alkaline. Okay, so the group 1 metal react with water to produce alkaline hydroxide ion, and indeed that's why they are called alkaline metals. Okay, they produce alkaline hydroxide ions. Now, so we have the general equation: water plus alkaline metals, you get alkaline metal hydroxide plus hydrogen. All right, that's the general equation. You should be able to write down the word equation for lithium, sodium, and potassium as they react with water. You should be able to write them down. Now, how does lithium react with water? Let's look specifically at lithium. Now, lithium is the least reactive of all the alkali. Why? Lithium is the least reactive of all the alkali metals. Why? Now, when lithium reacts with water, when we add it, it fizzles and moves slowly across the surface of the water. Okay, so when we add lithium to water, it fizzles and moves slowly across the surface of the water. Now, you should be able to write the word and the full equation for that reaction. Let's look at sodium. Sodium, when we add it to water, also fizzles. It also fizzles, but more. Okay, it fizzles more and moves quickly across the surface of the water. Okay, so like lithium, sodium also fizzles, but in this case more than in lithium, and also move across the surface of the water quicker than lithium. Now, sodium melts as it reacts and becomes spherical and shiny like a ball bearing. Okay, so in addition to fizzling, sodium melts as it reacts and becomes spherical. Additionally, the hydrogen that is produced when sodium reacts with water can catch fire because of the heat it produces. Okay, the hydrogen can catch fire because of the heat it produces. So the general equation is that sodium plus water, you will get what? Sodium hydroxide and hydrogen. Okay, this is the full balanced chemical equation. You have to make sure you can write them down. All right, so sodium reacts with water to produce sodium hydroxide. What product are you going to get if potassium reacts with water? What will be the product? Pause the video and write the full word equation and balance equation down. Pause the video and write the full word equation and balance equation down. How does potassium react with water? Now, when added to water, potassium moves across the surface of the water quickly, far quicker than what happens when sodium is dropped on the surface of water. Now, sodium, like sodium, it melts with the heat of the reaction. Now, remember we said that when sodium reacts with water, it melts. That also happens when potassium also reacts with water. Okay, the reaction produces so much heat that the hydrogen catches fire. Now, if this happens, if potassium reacts with water and the reaction produces so much heat that it catches fire, what color will be the flame? Remember the flame test we did. What will be the color of the flame if it is potassium? Now, so over here we have the general reaction of potassium with water. We have potassium plus water, we will get potassium hydroxide. Remember, the general principle is that the alkali metals react with water to produce metal hydroxide and hydrogen. Okay, again, you should be able to write the full balanced chemical equation and that of the word equation. Now, in the next video, we will look at how they react with chlorine, how the alkali metals react with chlorine.